Imagine you want to sell some tokens or trade an NFT. One way of doing it is through two transactions. You send the tokens or the NFT, and then the buyer sends you whatever you agreed to as payment. But what if the buyer never sends the payment back? In that case, you lost it. To make a more secure trade, you can use a swap contract sort of like this one. You can lock the tokens or the NFT in this validator and provide the beneficiary, that is you, and the price that you are willing to accept. And then if someone wants to actually get those tokens or the NFT, it has to pay you the agreed upon price in the same transaction. Let's see how it works. First, we create a custom datum containing the beneficiary of the payment, that is usually the person that creates the output. So if you want to create the NFT, you have to put your own public key hash as beneficiary and the price you are willing to accept. And this is the only input needed for the validator. We provide this custom datum and the unit as redeemer. And then the only check we do is to make sure that when someone consumes this output, that there has to be another output to you, the beneficiary, with the price in the datum. How do we make this check? Well, we first get the value paid to the beneficiary that is inside the datum. In this case, we are checking between all the outputs of the transaction how much is paid to this public hash, the beneficiary. And we ask that this has to be equal to the amount of ADA contained in the price of the datum. So this integer here, this integer represents the price ADA. We could create a more general value type, so you could get paid with tokens or NFT, but in this case, we want to get ADA back. And that's it. The only thing we're doing here is to check that whoever consumes this output pays us whatever price we have in the datum. Now, this kind of works, but it has a huge vulnerability. What if I create two outputs with the same price? In that case, a malicious person could consume both UTXOs and only pay for one, because we only check that whoever consumes the UTXO has to pay us this predefined price. If several outputs have the same beneficiary and same price, all those outputs will be satisfied by a single payment of that price. This double spending issue has several solutions. One of them is adding an identifier to the datum. So even if the same person asks for the same price, it has different quote unquote ID values or reference values. And another one, for example, is to make sure that a single output is being consumed by the transaction. So this week's homework is to create the tests needed to catch this vulnerability. And once those tests works as expected, you have to fix the validator and run this test again to make sure that now is resistant to double satisfaction. As a little help, this is how the test should look like before fixing the validator. There you go. As you can see, the normal spending was okay. The normal spending is user 1 creates a UTXO selling an NFT for 10 ADA or whatever. User 2 pays 10 ADA and gets the NFT. Everything is okay. Normal spending works. This works with the current smart contract. But the double spending, in this case, user 1 creates two UTXOs selling two different NFTs but at the same price. And user 2 tries to pay for just one NFT but takes both. This double spending fails, as you can see, because we expected this action to fail because you shouldn't be able to get two NFTs for the price of one, but it succeeds. Once you get to this point, it means that your tests are running okay, so you can try to fix this smart contract. If it happens to be too difficult or you get stuck or whatever, remember that you can ask us at Discord, but also I will wait for a week and then release the solution in the solutions branch. Happy coding!